Okay, let's look at question number 14, part A, the graphing question using differentiation. So, given this is ax squared. So, x is not equal to 2, fx is given by this, and in fx curve, y-intercept is 0. Then we have to show c equals 0, right? So, y-intercept is 0. Y-intercept is 0 means when x equals 0, function value is 0. Because y-intercept is 0, y value is 0. So, we'll use that. So, 0 equals a into 0 squared, b into 0 plus c minus 2 squared. So, what do we have? C over 4 equals 0, or c is equal to 0. So, that part is done. Then, they have given in second part, y equals minus 1 is a horizontal asymptote. Y equals minus 1 is a horizontal asymptote. Then for any value of b, a value has to be minus 1. We have to show that. So how do we find horizontal asymptote? We look for the limit as x approaches infinity or minus infinity. So we'll do infinity, ax squared plus bx plus c, x minus 2 squared. So this is x squared minus 4x plus 4. I just expanded it. This is going to be equal to 1. No, minus 1 according to the given data. Y equals minus 1 is a horizontal asymptote. So then find the limit. What is the limit going to be? You can do divide each term by x squared. So b over x, c over x squared, 1 minus 4 over x plus 4 over x squared. This is going to be equal to minus 1. So apply the limit. A, all these terms going to be 0. 1 minus 0 plus 0 equals to minus 1. So a is equal to minus 1, right? So that part is also done. Then third part is what? Now we know a, we know c, we have to find b. A is a stationary point, then b is equal to 3, we have to show. So stationary point is on the curve, no? So this is a point on the curve. Any stage, this is a turning point or stationary point. So any turning point or stationary point is on the curve. So we just need to substitute that. When x equals 6, y equals minus 9 over 8. So let's substitute that and find this. When x equals 6, y equals minus 9 over 8. So substitute that into the function. This is a point on the function. So a is what? A is minus 1. So minus 6 squared minus, so b is what we want to find. So 6b. C is 0. So that is 0. 6 minus 2 whole thing square. So let's simplify. This is what? 4 squared 16. So I will multiply that out to this side. And this side is what? Minus 36 plus 6b. Plus 6b. Plus 6b. So what do we have? This and this cancel to 2. So minus 18 minus 36 plus 6b. So 18 equals 6b or b equals 3. right? That's what we wanted to show. So right, that part is also done. Then what's the next part? For these values of a and b and c, we have to show the first derivative is equal to this. So right, so let's write down fx now using the values we found. Fx is minus x squared plus 3x over x minus 2 whole thing squared. Right, so now let's find the first derivative. F dash x is what? Using the quotient rule, apply the quotient rule. Fourth power x minus 2 square within brackets minus 2x plus 3 minus within brackets minus x squared plus 3x 2 into x minus 2 into 1. Right, so now let's simplify. We can cancel what? 1 x minus 2 term. Each one has x minus 2. Right, we'll do that. Then simplify the numerator. You have x minus 2 minus 2x plus 3. This one you have minus 2 minus x squared plus 3x. Denominator is x minus 2 cube. Right, so let's look at the answer. So it should end up with x minus 6 on the numerator. Denominator part is done. X minus 2 cube we have. So numerator just simplify. Minus 2x squared plus 3x plus 4x minus 6 plus 2x squared minus 6x. Two x squared cancel. 7x minus 6x is x and minus 6. Right, you have the correct expression. So there is the first derivative. That's what we needed to show. So this is also done. Right, hence find the increasing and decreasing intervals and check the stationary point whether it's a local max or min. Right, so we'll do that. So let's first find the critical values. So what are the critical values? X equals 6 and x equals 2. Right, those are the two critical values. F dash, you have to equal f dash to 0 and you get one critical value. F dash x equals 0, what do you get? X equals 6, and f dash x does not exist when x equals 2, right? So now we can break the number line and in each interval we can see what happens to the function, whether it is increasing or decreasing using the derivative sign. So I will use some test values. I will use in the first interval 0. What happens if I substitute 0? Numerator becomes negative, denominator also is what? Negative cube, which is negative. No? So negative divided by a negative is positive. So in this interval increasing. Then check 2 to 6. Easy test value 4. What happens if I substitute 4? 4 minus 6 is negative. This one positive cube. Negative, positive cube is positive. So this is negative. So in this interval decreasing. Then final interval greater than 6. So let's put 10. So 10 minus 6 positive, positive, positive. So it is increasing in that interval, right? 10 minus 6, yes. So then we have the increasing intervals and decreasing intervals. And the only stationary point is 6, no? Let's check whether it is a local max or min. Decreasing, then increasing. So this is what? Local minimum. Local minimum at x equals 6. So let's find the y value, corresponding y value. So we have to substitute 6 into the function. So where's the function? This one. I have to substitute here. So minus this one I don't need to find. No. They have given that point. No. Stationary point is what? 6 comma minus 9. No, wait. When you substitute also you should get that value. So this is the local minimum. The point is 6 comma minus 9. No, wait. Right. So then let's write the answers. Increasing intervals. There's 2. Negative infinity to 2 and 6 to infinity. Decreasing intervals are what? The middle interval 2 to 6. And we have a local mean where 6 comma minus 9 over 8. Right. So that is done. Then what are they saying? Second derivative is given to us. This is the second derivative. Then using that, find the inflection point coordinates and concaving up and down intervals. Right. So we'll do that then. What is second derivative? F double dash is equal to what? Minus 2x minus 8 minus 2x minus 8 over x minus 2 to the 4, x minus 2 to the 4th power. Right. So then again break the number line, equal the second derivative to 0, then you get 8. Second derivative does not exist when it is 2. Right. So then in each interval check using test values like we did for the first derivative. Now we are looking for the second derivative sign, because second derivative sign determines concavity. If it is positive, concaving up. If it is negative, concaving down. So first interval, let's use 0. What happens? Minus into minus positive. Denominator is always positive. So the sign depends only on the numerator sign. So negative into a negative gives you positive. So in this interval, positive. Then the second interval between 2 to 8, I will use 4. So then this is minus till. Minus into minus is again positive. So again in this interval also concaving up. Then the final interval more than 10. So this is positive. Minus into positive becomes minus. So in this interval negative. So concaving down. Right. Only inflection point can happen at 8. So let's see if it is an inflection point. Yes. Concavity changes no, from up to down. So 8 is an inflection point. So we'll find the value, the y value. X equals 8. So corresponding y value is what? Substitute into the function. This one. So minus 8 squared is minus 64. Minus 64 plus 3 into 8 is 24. X minus 2 squared. So 8 minus 2 squared is 6 squared, 36. So what do we have? Minus 40 over 36. Minus 10 over 9, right? Minus 10 over 9. Yes. So then concaving up intervals are what? Negative infinity to 2, 2 to 8. Concaving down interval is 8 to infinity. And the inflection point is 8 comma minus 10 over 9. Right. Okay. So that's also done. Now, what's the next part? So up to here we have done. Then we have to show the intercepts on the axes, asymptotes, turning points, inflection points, and draw the diagram. Right. So inflection point and turning point we are done, and y-intercept is 0, and x-intercepts we have to find. So let's find the x-intercepts. What is the function? Minus x squared plus 3x, x minus 2 square. So we want x-intercepts now. So function equals 0. So that means minus x squared plus 3x equals 0. So that is x squared minus 3x equals 0. So factor. So x equals 0 and x equals 3 are the x-intercepts. Right. So those are the x-intercepts. Y-intercept is just 0. And we have the horizontal asymptote, which was y equals minus 1. What is the vertical asymptote? Vertical asymptote is x equals 2, right? From here, denominator becomes 0 when x equals 2. No? So then that is the vertical asymptote, right? So, right. So we have everything now. We have horizontal asymptote, vertical asymptote, x-intercepts, and the turning point. The local mean value was what? Local mean value was 6 comma minus 9 over 8. Inflection point was 8 comma minus 10 over 9. Then let me write the increasing decreasing quickly here. Increasing was what? Minus infinity to 2 and 6 to infinity. Decreasing was 2 to 6. And the concaving up was minus infinity to 2 and 2 to 8. Concaving down was, sorry, this is 2 to 8. Yes, 2 to 8. So concaving down was 8 to infinity, right? Right, now using this data, we have to draw the diagram, right? So first mark the asymptotes. Y equals minus 1 and x equals 2. Y equals minus 1. One, 2. Let's do x. No, if we draw it like that, that's going to be hard to. We need 6, right? 1, 2, 3, 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right. Then through 2 you have your vertical asymptote. Right. So let me put this arrow so that I can easily draw this. Right. Now we have marked the asymptotes. Now mark the, so this is done, this is done. Intercepts 0, 3, 0 and 3. Those are the x-intercepts. Right, that is also done. Then what? Local mean and inflection. Min is at 6, minus 9, 6, 3, 4, 5, 6 here, and then minus 9 over 8, minus 9 over 8. So let's say right around here, we'll put it like that. Local mean. Right, then inflection point is where? 8 comma minus 10 over 9. 8. So somewhere here, let's mark. That is the inflection point. Right, now we have to draw this. Right, we'll start with negative infinity to positive 2. This section. Negative infinity to positive 2. What is happening? Increasing and concaving up. Increasing and concaving up. So which two arrows should I connect? This red arrow to this red arrow. Then it is decreasing shape. No? So this red arrow to that red arrow. It has to go through the x-intercept. So let's correctly draw this. Right. So that is the concaving up and increasing. So that section is done. Then the next section. So then let me erase these two arrows. These two arrows are not required. Right. Next section is from 2 to the local minimum point. It has to go through this intercept 3, 2 to 6. Let's check what happens. 2 to 6. 2 to 6 decreasing and concaving up. Decreasing, concaving up. So which arrows should I connect? Should I connect this arrow to here? No, that is increasing. No? This arrow to here. Because we want concaving up and decreasing. So has to go through 3. And it's a local min at here. Concaving up, correct. Now next point is 6 to the inflection point. So up to there you are going to have a concaving up shape, then concaving down shape from there onwards. So that's the full graph. So this point is what? This is 6 comma minus 9 over 8 local minimum point, and this point also mark inflection point 8 comma minus 10 over 9. Right, everything is marked. Erase these arrows. So this is our vertical asymptote, and this is the horizontal asymptote, right? So that's the curve that we were supposed to draw, right? So that part is done. Sketching part is done, right? So this is a long question. There's more to it, right? So now using the sketch, we have to show what? We have to find the k values for which this one. So has one solution like that. Okay, let's see what this one is. So let me write that one. K plus x squared. K plus 1 x squared k plus 1 x squared minus 3 plus 4k x plus 4k equals 0 plus 4k equals 0. Right. So now let's convert this into the correct form. Kx squared wait, how to do this? Let's see, kx squared x squared minus 3x. Let's just get rid of brackets. Minus 4kx plus 4k. Right. Let me group the k terms together. K, if you take k out, you get x squared minus 4x plus 4 inside. Other two terms, let me move to the other side. Minus x squared plus 3x. So this one is what? This is x minus 2 whole thing square. So x is not equal to 2. No? So let's divide by that. So k is equal to what? Minus x squared plus 3x. X minus 2 square. So this is what actually? This is the function. This is the function. So we are trying to solve what then? Fx equals k. Solving this is same as solving fx equals k. So how do you solve that type of equation using a curve? Fx we drew. What is k? K means y equals k. It's a horizontal line. So then let's see, according to the where line falls, you can have different number of solutions. So let's see what is part A. Or part alpha is what? This should have only one solution. So then what should happen? If you draw y equals k line, if I draw it like that, two intersection points, no? So that is not correct. We want one solution. So where is the one intersection point? That point. So if you draw y equals k line through there, that is the only intersects at one point. No? So what is the k value for one solution? Minus 1. So alpha answer is minus 1. Then beta is what? Two solutions, but they have to be identical. So that is where then your line, your horizontal line should intersect what? A stationary point. So this point. So that line should go through where? Minus 9 over 8. If k value is minus 9 over 8, y equals minus 9 over 8 only intersects at the stationary point. So then you will have what? A pair of solutions, but both are identical. So k is minus 9 over 8 for that one. Then let's look at the next part. Two different. not identical, two different. So then you have to have two intercepts, two intersection points. So draw some lines, two intersection points, two intersection points, two intersection points, two intersection points. So again two intersection points. So you can go from where to where. First you can do from -1 upwards, right? Anything above -1, k value -1 works. You get two intersection points. So -1 infinity, k can be greater than -1. And what's the other range? Between -1 and 9/8 also works. No? Between this point and -9/8 also works. So union -9/8 to -1. Right. So in that range, you will have two, not identical, two different solutions. Right. Then last one is what? Last one is no real solutions. So then where do you not intersect the curve? So if I draw lines after -9/8, no intersection points. So then that's the answer for that one. K has to be what? Less than -9/8. So minus infinity to -9/8. Right. So that is the full answer for question number 14, part A. Right. So then we'll do the second part, part B of this question next.